Hi students, in this lecture I am going to discuss problems from previous IIT. Let us see first one. See the question given. Consider a spherical gaseous cloud of mass density rho of r in free space where r is the radial distance from its center. The gaseous cloud is made of particles of equal mass m moving in circular orbits about the common center with the same kinetic energy k. The force acting on the particles is their mutual gravitational force. If rho of r is a constant in time, the particle number density, that means density by mass of particle. This is what we have to calculate. So here you can see key points. It is a spherical gaseous cloud. Density rho of r. That means we can take this as combination of spherical shells, right? Next, we are given one more point, equal mass, and they have same kinetic energy k, right? About common center. Let us see how we start the problem. Let us consider a particle which is now following circular path. Let us take radius is r. So when we are focusing this particle, all particles which are confined to the such sphere, I am repeating, all particles which are confined to this region, they exert a force on this one. Okay. And all particles beyond this region, all particles beyond this region, or you can say beyond this sphere, do not exert any force. The reason is that we have learned in shell theorems a uniform distribution of mass means a shell having distribution of mass uniform, then at any point inside there is no gravitational force. Okay, so using that logic, all points out of this sphere do not exert a force on this one. So force is only because of the points which are confined to this sphere. Okay. Now see force acting on this particle, gravitational force. I am taking this mass as m and particle mass is given as a small m. So force acting on that G m1 m2 by r square. This gravitational force is a providing centripetal force. So which is equal to m into centripetal acceleration is v square by r. Okay. So from this, see what we get. We get the value of mv square. One r gets cancelled. We got mv square equal to gm by r. Mv square, it is g m m by r. Now multiply with a half both sides. Okay. So this is nothing but a kinetic energy of a particle, right? And here we want to calculate density as a function of r. If it is known, we can divide this with the mass of particle. So to know this, what we can do? See how to find mass, this Kaplan. So we can take this sphere as combination of shells. So for one shell mass will be 4 pi r square into dr. This is volume of that shell. Okay, into density. That gives mass of the particles confined to that shell. Take it as dm. Okay, take it as dm. Like this, we have to consider all shells and we have to find mass in all those shells. So taking sum of all those things gives us Kaplan. Okay. So now what I can do here, from here, see what is capital 2rk upon g small m. We are having here dm. So I'm finding dm from that expression. dm is equal to 2k by gm into dr. Now take this result in this one, then see what we get. 4 pi r square into dr into rho of r is equal to 2k by gm into dr. So dr gets cancelled. From this you are going to get rho of r is equal to, and 1 2 also gets cancelled here. It is now rho of r equal to k by 2 pi g m r square. Check it once. Rho of r equal to k by 2 pi gm r square. Okay, this is rho value. Now number density. Number density is given by rho of r dividing with mass of particle, and that is equal to k by 2 pi g m r square, sorry, m square r square. That is now our answer. Okay. And here some students getting a doubt like, by by integrating this, we can get mass capital and we can equate this one to here, this equation. Suppose this is 1 and this is 2. So some getting a doubt like, by integrating 2, we get capital. Now we can equate that, this capital. But the problem is here, we are not knowing what is rho of r, how it depends on r. That's why we are not doing integration here, okay? So we are just differentiating this and make it equal to this one. So we cannot integrate this to get mass. Okay, right. Let us see next one. Let's see the question. A bullet is fired vertically upwards with velocity v from the surface of a spherical planet. When it reaches maximum height, its acceleration due to planet's gravity is 1/4 of its value at the surface of the planet. So key point is here, it is 1/4 of its value at the surface of the planet. If escape velocity from the planet is v root n, then the value of n is, okay. So we have to ignore energy loss due to atmosphere. So this question is asked in 2015 advance. So first write down given data. Right. So first I'm writing here, at a height h, given its value is 1/4 of that on surface. Right. So now we have to calculate what is escape velocity. Escape velocity is given as v root n. So what is the value of n? We can see here, we are knowing that with the height, how g value changes. G into square of r upon r plus h, right? So this is g by 4, right? So this is g by 4 means h equal to r, right? It is g equal to r. Now, to reach a height h, how much velocity we have to provide? So projecting from surface of the planet, right, to reach a height h equal to r, h equal to r. So we can use now energy equation. We can use energy equation. See carefully. At the time of projection, potential energy minus Gm by r, potential energy, plus kinetic energy half mv square is equal to height is now r. So only potential energy. So h plus r. It is now becoming 2r, right? So from this half mv square is equal to, take this one to right side. So 1 minus 1 by 2, it is 1 by 2. So Gm by 2r. So 2 cancels and mass cancels. So V value root of Gm by r. Okay. But escape velocity is now root of 2Gm by r. So from this we can say n value is 2. So it is a very simple question. Just we have to use energy conservation and this result. Okay, right. See next problem. Two spherical shells of mass, two spherical planets P and Q have same uniform density rho, masses MP and MQ, and surface areas A and 4A respectively. So from this we can say uniform density masses. Surface areas are A and 4A. It means if first one radius is R, second one is 2R, right? A spherical planet R also has uniform density rho and its mass is mp plus mq. The escape velocities from the planets P, Q, and R are Vp, Vq, and Vr respectively. So this is asked in 2012. So we have to verify the relations. So first key point we got radius, right? R and 2R. Now third one is masses are sum of these two. Right. First write down the given data. Right. First of all, given here, radius is A, sorry, surface areas are A and 4A, right? That means radius of Q is 2 times of radius of, okay. Next, coming to third one, it is given that its mass equal to sum of these two masses. Mass of R is equal to mass of P plus mass of Q. So we have to compare now their escape velocities. If you observe carefully, escape velocity is equal to root of 2Gm by R. Asking surface, from surface, see here what we can do. G is a constant. Since we are given density same, key point, Density is same for all. Density is same for all. Therefore, so two constant G constant, mass is volume into density. And volume 4 by 3 pi r cube. This is r cube and this is r. Remaining is now r square, right? R square means proportional to root r square means this is a proportional to escape velocity proportional to r. Okay. So no need to worry about their masses. I am repeating here. Since density given same, writing mass as volume into density. Volume 4 by 3 pi r cube. R cube and r square. So root r square, that is r. So escape velocity proportional to r. Okay, right. Now see here what we can write. First thing we can say clearly that ratio of means velocity, escape velocity from q by escape velocity from p. This will be per q. Radius is twice that of p. And we are knowing here velocity proportional to r. Therefore, it is equal to 2. Directly we can say that. Okay. And one more thing here. When you are taking mass of r is sum of these two masses, right? Then definitely I can say radius of r is greater than radius of q as well as radius of p. Okay. Radius of q as well as radius of p. That means we can say clearly that escape velocity from r greater than escape velocity from q greater than escape velocity from p. Right? This we can say directly. And next we got condition that Vp by Vq is 1 by 2 or Vq by Vp is 2. Right? This also we can say directly. Now remaining is Vr by Vp. Vr. See how to find Vr. Then see what I am doing here. Equating. So from this mass of R means its volume. Its volume 4 by 3 pi R cube. I am taking it as R suffix R, okay, into density. That is equal to for P. For P, what we can write? 4 by 3 pi R cube into rho plus 4 by 3 pi. It is now 2R. 2R whole cube into rho. Check it once. For Q, radius is 2 times of that of P. Okay. So throughout what happens, 4 by 3 pi gets cancelled, rho gets cancelled. R cube for R is R cube plus 8 R cube. It is 9 R cube. That implies radius of that R will be 9 power 1 by 3 into R. Right? That means when it comes to VR by VP, VR by VP, that will be VR. So it is a 9 power 1 by 3R by R. It is 9 power 1 by 3. That means it is not equal to 3. Okay. So like this we can solve the problem. See next one. Right. See the question given. The distance between two stars of masses 3 times of mass of sun and 6 times of mass of sun is 9R. Here R is the mean distance between the centers of the earth and the sun and ms is mass of the sun. The two stars orbit around their common center of mass in circular orbits with a period n times of t, where t is the period of Earth's revolution around the Sun. The value of n is. This question is asked in 2021 for 4 marks. Earlier, if you remember, question number 4, we have solved 2-point masses m1 and 2 revolving about their common center of mass. Find time period. Now this is again same problem. It is now again same problem. So first write down given data, masses, 3 times of mass of Sun, 6 times of mass of Sun. Separation is given 9R. Right? We have to find time period of revolution. Let us take it as T dash. This is now given as n times of time period of revolution of Earth around Sun. I'm just recollecting once. We have discussed that question number 4, you can refer once, M1, M2. Separation is R. They are revolving about their common center of mass. Find time period of revolution. I'm writing briefly. If I'm focusing M1, force acting on M1 because of M2 provides now centripetal force. G M1 M2 by R square. That is equal to mass into centripetal acceleration. Now, distance of center of mass from M1, that is M2R by M1 plus M2. So, M1 R1 omega square. So, here M1, M2, M1, M2 gets cancelled. Omega square is equal to G into M1 plus M2 upon R cube. That means now time period is 2 pi root of R cube by M1 plus M2 into G. Right? Now substitute values in that. Let us take this as T dash. So T dash equal to 2 pi root of R cube. R cube means 9R, right? 9R whole cube upon G into sum of their masses 9 ms. Right? So this is equal to 2 pi root of 9 gets cancelled. Remaining is now 9 square R cube by GMS. Right? So this is now 9 times of 2 pi into R cube by GMS. Okay. This is 9 times of the time period of revolution of Earth. So n value is 9. So it is a very simple one. Right? See next problem. See what is the question given here. Distance between two stars is 10A. The masses of these stars are M and 16M and their radii A and 2A respectively. A body of mass M is fired straight from the surface of the largest star towards the surface of the smaller star. What should be its minimum initial speed to reach the surface of the smaller star? So we have to get it in terms of G, M, and A. Okay. So this question is asked in 1996 for 5 marks. So first note down the given data masses M, 16M, their radii A and 2A. And separation given 10A, projecting from bigger one to smaller one. Right now, see carefully. First of all, the given data M16M projecting from bigger one towards the smaller one. Okay, towards the smaller one. Mass is M16M. Separation between the centers is given as now 10A and given the radii A and 2A. We have to find minimum speed so that it will reach the surface of the smaller one. So here we have to focus carefully the meaning of minimum speed. You can see when we project here, initially the attractive force of this bigger one is dominating compared to that of a smaller one. But you can see somewhere in between the stars at one point, attractive force by smaller one and that due to bigger one, both will cancel because one is right and one is left. Somewhere it will be cancelled. If you provide velocity in such a way that if you provide velocity in such a way that it is just able to cross this point, just able to cross. If it is just able to cross, then because of its attraction, it moves of its own. That means we are giving velocity in such a way that on reaching this point, its velocity becomes zero. The meaning of minimum velocity. Okay. And you can see at which point net force becomes zero. See carefully once. Suppose this is now distance x from smaller one. We are taking from center, okay, from center of the smaller one. Distance is x. Because of a smaller one, force is g m m by x square. This force should be balanced by. So I am equating here their magnitudes g 16m small m by 10 minus x whole square. So m gets cancelled. Remaining is now 16x square, that is a 4x. 4x equal to 10 minus 6. That implies 5x equal to 10, x equal to 2a, right? So at this point, attraction by smaller one, attraction by bigger one, both will be cancelled. Okay. So now I am using here energy equation. So writing law of conservation of mechanical energy. See what is that? At the time of projection, kinetic energy half mv square. Potential energy of the bigger sphere, because of the bigger sphere, potential energy minus g m by radius is 2a, and because of a smaller sphere, potential energy minus g m1 m2 by distance from center to up to here, that is now 8a, right? Because center to center separation is 10a, so up to here means it is 8a because radius is 2a, right? That is equal to on reaching this point only potential energy, because we are providing minimum speed. So no speed means on reaching this point its velocity becomes zero, means just crossing this point, just crossing, therefore only potential energy. So minus g, because of a smaller one, m separation equal to 2a from center. Next, because of bigger one, g 16m by separation equal to, it is 8u. Okay. So now we have to Now we have to solve this one. So throughout m gets cancelled, right? On throughout 2 also gets cancelled. 2, 2, it becomes a 4, this 2, and this becomes a 4, right? So from this, we are going to get V minimum after simplifying this. V minimum comes out to be, I'm taking directly here, 3 root of 5 upon 2 root of gm by a. After making that calculation part, we are going to get 3 root 5 upon 2 into root of gm by a. This is a final answer. So key point is that on reaching this point, its velocity becomes zero, means just crossing that point. Then because of its gravity, it moves automatically. Okay.